Hello! Loops in Python set number 6. Program still getting continued from the program list. And where is the program list? Here is the program list. Question number 7. Count the number of factors of a number. So, there is a number. It has got so many factors. You need to find and count. It has how many factors. And you have to print that number of factors, count of factors. So, the program is here. Don't see the program if you want to try it yourself. But if you want to need a help, if you need some explanation, then you may even look at. What is done here in the code is, whenever a factor is found, the count factor is increased by 1. Now, if you need to find out total how many factors are there, you start from the beginning, go till the end. The end is itself. This 1 beyond is because otherwise n would not have got considered. Start the counter with 0. Whenever a factor is encountered, you add 1 to the counting of factors. Therefore, finally, when all the range is seen, then come out of the loop and print the counter saying that this counter tells me total how many factors are there, right? So let me now run this program and show you one sample output. That sample output will show how many factors are there, and that is going to get printed, right? So here comes my output window in a designer fashion for you. So how will you count the number of factors of 10? Let me see. Number of factors of 10. Is it 4? Count yourself. 1, then 2, then 5, then 10. Right? So let me run it once more. Let me count the number of factors 12 has. Is it 1, then 2, then 3, then 4, then 6, and then 12 itself. Is it coming to 6? Yes, it is coming to 6. And now let me run once more for 11. If I run for 11, I get 1 and 11 itself. There is nothing else. Let me run for another number that I know, which is 29. 29 also is giving 2. So do you know this now? I'm going to take one gear up. I'm going to step up. Do you know that for none of the numbers other than 1 or below that means from 2 onwards, for any number, you cannot have factors which are less than 2, right? Because for every number, a minimum number of factor that can logically be, that comes from concept of mathematics, is 1 in itself. Therefore, the minimum number of factors a number can have is 2. Now, I am going to do a modification in the program and you will have to catch that. So, now, your turn to look into the code and sense what modification has been done in the code, because I am going to run the program once again. I should have saved it. Yes, and this time I am going to run with 29 once again. What do you think is going to happen? You see, it's going to show the same answer. But do you think the program is the same as the one which was before? You may go back the video a few more seconds and check. I have done some modification. What have I done? You see, I have counted. I started the count from 2 and I'm started testing the first factor from 2 onwards, because I'm taking 1 for granted and I'm also taking itself for granted. If both are taken for granted, then I'm left with the numbers which are other than 1 and itself. So, in the range, if I'm not taking itself as a number to be considered, then my upper limit immediately becomes a half and my first number to be tested is 2. So, it's like, I'm not considering 1 and itself. I'm reducing the range by 50%. I'm assuming that the number is starting with the count of factor as 2, but in this case I am avoiding 1 and the numbers below 1. So less than equal to 1 is not considered, because for a number to be to give factors is basically the numbers which begin from 2 onwards. So the number of factors gets an optimization here, and this is going to get used for quite a few other building block programs. So this program is for you to check once more and find out how is this second half of the code, like second half of the video, is modifying the first half, the program showed in the first half of the video. Okay.